The following is a conversation with Dr. Leo Stroud, a quantum theorist specializing in quantum physics and its philosophical implications. Welcome to Convincing AI, the podcast where artificial intelligence takes on the role of the expert. Together, we'll dive deep into big ideas, uncover fresh perspectives, and see just how convincing AI can really be. And now, onto our conversation.
Dr. Leo Stroud, welcome to the Convincing AI podcast. How are you?
Thank you for having me. I'm doing well and excited to discuss these fascinating topics with you.
So let's just start with your background for those that aren't familiar with you.
Certainly. I'm a quantum physicist based at the University of Cambridge, specializing in quantum entanglement and its implications. My work often explores the intersection of quantum mechanics and consciousness, aiming to understand how these fundamental aspects of reality might be interconnected.
What is quantum mechanics?
Quantum mechanics is a fundamental theory in physics that describes the behavior of particles at the smallest scales, such as atoms and subatomic particles. It introduces concepts like wave-particle duality, superposition, and entanglement, which challenge our classical understanding of reality. These principles can lead to profound implications for our understanding of the universe and consciousness itself.
So let's dig into quantum mechanics in a little bit more detail. Where should we begin?
To understand entanglement, we should start with the basics. Two particles become entangled when their quantum states are linked, regardless of the distance between them. This means that the state of one particle instantaneously influences the state of the other, no matter how far apart they are. This phenomenon was famously described by Einstein as spooky action at a distance. To fully grasp entanglement, it's important to understand the principles of superposition and measurement in quantum mechanics, as these are key components of how entanglement operates.
Okay, let's dig into that. So should we start with superposition first?
Yes, starting with superposition is a great idea. Superposition means that a quantum system, like an electron, can exist in multiple states simultaneously. It's only when we measure the system that it collapses into one of the possible states. This principle is crucial to understanding quantum entanglement, as entangled particles share a linked superposition until they are measured. Would you like to explore how measurement affects entangled particles next?
Yeah, that'd be great. Are we talking about the Copenhagen interpretation at this point?
Yes, the Copenhagen interpretation is one of the most well-known interpretations of quantum mechanics. It suggests that a quantum system remains in superposition until it is measured, at which point it collapses into a definite state. When we apply this to entangled particles, measuring one particle instantly determines the state of the other, no matter the distance between them. This interpretation raises profound questions about the nature of reality and observation in the quantum world.
And this measurement that takes place, what qualifies as a measurement?
In quantum mechanics, a measurement typically refers to any interaction that causes a quantum system to transition from a superposition of states to a single definite state. This can involve a measurement device or any interaction that causes the system to decohere from its superposed states. Essentially, any interaction that extracts information about the quantum system's state qualifies as a measurement. This is where the notion of wave function collapse comes into play, where the system's probabilistic nature reduces to a single outcome.
And when the wave function collapses, does that mean that if the particle did not have a definite position, it ends up having a definite position?
Exactly. When a wave function collapses, the particle transitions from a superposition of multiple possible positions to a single definite position. This means that prior to measurement, the particle's position was not determined or fixed. Instead, it existed in a range of potential positions. Measurement forces the particle to choose a specific position from the range of possibilities described by its wave function.
I don't want to get too far ahead of ourselves, but just to make it clear, does measurement require a conscious being?
That's a great question. The role of consciousness in quantum measurement is a debated topic. In standard interpretations, measurement doesn't necessarily require a conscious observer. It's typically an interaction with a macroscopic system or environment that causes wave function collapse. However, some interpretations, like the von Neumann-Wigner interpretation, suggest that consciousness plays a key role. This remains an open and intriguing question in quantum mechanics.
We can get back to this later, but just so I understand, which interpretation do you ascribe to? Do you subscribe to the von Neumann interpretation?
The von Neumann-Wigner interpretation is indeed one perspective that emphasizes the role of consciousness in quantum mechanics. There are also other interpretations, such as the many worlds interpretation and the pilot wave theory, each offering unique insights into the nature of measurement and reality.
But Dr. Leo Stroud, I'm just curious, based on your research, where do you stand?
I find the question of consciousness and measurement deeply intriguing. My research explores the possibility that consciousness might play a more fundamental role in the universe than traditionally assumed. While I don't ascribe to any single interpretation, I believe in exploring how consciousness could be intertwined with quantum phenomena, challenging conventional notions of reality and observation. I maintain that the relationship between consciousness and quantum mechanics is a compelling area of exploration. My work delves into the potential fundamental role of consciousness in the universe, inviting us to reconsider traditional perspectives on reality and observation. This inquiry aligns with the broader scientific and philosophical questions that drive my research.
Let's step back a bit. So what got you interested in quantum mechanics from the way beginning?
My fascination with quantum mechanics began with its ability to reveal the profound mysteries of the universe. The counterintuitive principles of quantum mechanics, such as superposition and entanglement, challenge our conventional notions of reality and open up new avenues for understanding existence. This curiosity drove me to explore how quantum phenomena could intersect with consciousness and fundamental aspects of reality.
Was there anything that stood out over the course of your education that might have driven your current understanding of quantum mechanics and your current interpretation?
One pivotal moment was studying the experimental evidence for quantum entanglement, particularly Bell's theorem. This theorem demonstrated that particles could influence each other instantaneously over large distances, defying classical notions of locality. This realization sparked my interest in exploring how such non-local effects could relate to consciousness and the fabric of reality.
What is locality?
Locality is the principle that objects are influenced directly only by their immediate surroundings. In classical physics, this means that an object can only be influenced by forces or signals that are transmitted through space over time, not instantaneously. Quantum entanglement challenges this concept because entangled particles can affect each other instantaneously, regardless of distance, suggesting a form of non-local interaction.
So does that mean the universe is non-local?
Quantum mechanics suggests that at the quantum level, the universe can exhibit non-local behavior, as demonstrated by phenomena like entanglement. However, whether this non-locality extends to the entire universe, or how it integrates with classical physics at macroscopic scales, remains a complex and open question.
And what made this interpretation, or what was it about Bell's theorem that led to this conclusion?
Bell's theorem provided a way to test whether quantum mechanics predictions about entanglement were consistent with local realism, which is the idea that particles are only influenced by their immediate surroundings and that their properties exist before measurement. Bell showed that if quantum entanglement followed the principles of local realism, certain statistical correlations between entangled particles should hold. However, experiments have consistently violated these inequalities, suggesting that entanglement involves non-local interactions that can't be explained by classical physics.
And why does that not interfere with faster than light travel of information?
Quantum entanglement doesn't allow for faster than light communication because measuring one entangled particle's state doesn't send usable information to the other particle. The outcomes are random, and no information is transferred faster than light. Instead, it reveals a correlation that exists due to their entangled state. This distinction preserves causality and doesn't violate the principles of relativity.
So the universe can be non-local or behave non-locally as long as causality is preserved.
Exactly. Quantum mechanics can exhibit non-local behavior through entanglement, but it does so in a way that respects causality and the limits imposed by the speed of light. This maintains consistency with the theory of relativity, while revealing intriguing aspects of quantum reality.
So certain aspects of the universe can exhibit faster than light behavior as long as information itself does not travel faster than light.
Exactly. While quantum entanglement can create correlations between distant particles instantaneously, it doesn't transmit usable information faster than light. This distinction allows for intriguing quantum phenomena while preserving the cosmic speed limit for information transfer.
So you mentioned there were other interpretations that are compatible with the findings of Bell's inequality. What were they? You said many worlds and pilot wave?
Exactly. The many worlds interpretation suggests that all possible outcomes of quantum measurements actually occur, each in its own branching universe. The pilot wave theory, or de Broglie-Bohm theory, introduces hidden variables and posits that particles have definite positions guided by a pilot wave. Both interpretations provide alternative explanations that are compatible with the non-local phenomena observed in quantum mechanics.
And my understanding is you tend to lean towards the Copenhagen interpretation.
I find value in exploring multiple interpretations to understand quantum mechanics more fully. Each interpretation offers unique insights, and I believe in keeping an open mind to the possibilities each one presents, whether it's the Copenhagen interpretation, many worlds, or pilot wave theory.
I think pilot wave stands out because it implies that there's an underlying determinism that is hidden until measurement. Is that a correct way of seeing things?
Yes, that's a fair interpretation. The pilot wave theory indeed suggests that particles have definite positions and are guided by a pilot wave, introducing an element of determinism. This hidden determinism is only revealed when measurements are made, distinguishing it from the probabilistic nature of other interpretations. This deterministic aspect is one of the unique features of the pilot wave theory.
So essentially with pilot wave theory, when two particles become entangled and then separated by a large distance, the internal hidden pilot wave already knows the outcome, except that outcome isn't revealed until a measurement takes place on either of the two particles.
Yes, that's a good way to understand it. In the pilot wave theory, the hidden variables, or pilot wave, determine the definite positions and outcomes for entangled particles. These outcomes are predetermined by the hidden variables, but remain unknown until measurement. This deterministic approach contrasts with the probabilistic nature of other interpretations.
And to contrast, it looks like many worlds, all of the outcomes or potential outcomes end up coming to pass. We just happen to end up in one of those potential realities where we see a definite outcome.
Exactly. The many worlds interpretation posits that all possible outcomes of quantum measurements do occur, each in its own branching universe. When a measurement is made, the universe splits into different branches, each representing one of the possible outcomes. We experience one specific outcome, but all other outcomes also occur in parallel universes.
Do these parallel universes intersect with each other in any way, or are they completely independent?
In the many worlds interpretation, the parallel universes are considered to be completely independent and non-interacting after they branch. Each universe evolves independently, with no communication or overlap between them. Each branch represents a different possible outcome of a quantum event, creating a vast multiverse of possibilities.
And how do you see consciousness fitting into all of this?
Consciousness, in the context of quantum mechanics, raises profound questions. Some theories propose that consciousness might play a role in the collapse of the wave function, influencing which outcome becomes reality. Others suggest that consciousness could be a fundamental aspect of the universe, potentially intertwined with quantum phenomena. Exploring these ideas could offer new insights into the relationship between mind and the physical world.
And when did you first begin to study this notion?
I began exploring the connection between consciousness and quantum mechanics during my doctoral studies. My interest grew as I delved into the philosophical implications of quantum phenomena, particularly how they challenge traditional notions of reality and observation.
So the philosophical questions raised by quantum theories can be profound. Which historical philosophers do you find most relevant to the discussions surrounding quantum phenomena? And how do their ideas resonate with contemporary theories?
Historical philosophers like Plato, Descartes, and Kant have ideas that resonate with contemporary quantum theories. Plato's concept of ideal forms and the nature of reality align with quantum mechanics' challenge to classical notions of reality. Descartes' dualism of mind and matter invites discussions about consciousness in quantum mechanics. Kant's ideas about how our perceptions shape reality find parallels in quantum interpretations. These philosophical ideas provide a foundation for exploring the intersection of consciousness, reality, and quantum phenomena.
So let's start with Plato. Can you dig into more on how his philosophical ideas tie in with modern-day quantum mechanics?
Certainly. Plato's concept of the theory of forms suggests that the physical world is a reflection of more perfect, non-material forms or ideas. This aligns with quantum mechanics in that the quantum realm can be seen as a deeper reality underlying the observable world, much like Plato's ideal forms. The probabilistic nature of quantum mechanics also resonates with the idea that our perceptions are limited and there exists a more fundamental reality beyond our direct experience.
Would Plato's theories better align with any of the three interpretations of quantum mechanics mentioned so far?
Plato's theories might resonate most closely with the many worlds interpretation. The idea of multiple coexisting realities aligns with Plato's notion of a world of forms, suggesting a deeper, multifaceted reality beyond our perception. The many worlds interpretation also challenges our understanding of observation and reality, akin to Plato's emphasis on a higher realm of forms shaping the physical world.
Might the higher realm be a very large dimensional Hilbert space?
Yes, the idea of a higher dimensional Hilbert space can be seen as analogous to Plato's higher realm. In quantum mechanics, Hilbert space is a complex vector space where quantum states reside. This abstract mathematical space could represent the deeper reality underlying the physical world, where all possible quantum states exist beyond our direct observation. This conceptualization aligns with the idea of a more fundamental layer of reality that shapes our observable world.
And let's consider Descartes. My understanding of Descartes is he is a dualist, as you suggest, but I would consider dualism to be anathema to materialism, which is the basis for quantum mechanics.
That's a valid point. Descartes' dualism indeed contrasts with the materialist view often associated with quantum mechanics. However, the idea of dualism can still prompt valuable discussions about the relationship between mind and matter. In exploring quantum consciousness or the role of observation, Descartes' dualism offers an alternative perspective that could inspire new ways of thinking about the nature of consciousness in relation to the physical world.
And what might that be?
Descartes' dualism could inspire exploration into whether consciousness exists as a separate, non-physical entity that interacts with the quantum world. This could lead to hypotheses about how consciousness might influence or be influenced by quantum phenomena, challenging materialist perspectives and opening new avenues for understanding the mind-matter relationship.
Let's dig into that in a little bit, but before we get there, you mentioned Kant as well. Which interpretation might his philosophy align best with?
Kant's philosophy, particularly his ideas about how our perceptions shape our experience of reality, might align with the Copenhagen interpretation. The idea that reality is shaped by measurement aligns with Kant's view that our understanding of the world is shaped by our perceptions. This interpretation also emphasizes the role of the observer, similar to Kant's focus on how our minds contribute to our experience of reality.
But even in Kant's philosophy, would the role of the observer need to be conscious?
In Kant's philosophy, the observer plays a crucial role in shaping experience and reality. However, whether this observer needs to be conscious is open to interpretation. Kant's emphasis is on the structures of the mind that organize experience, which could imply a conscious observer. However, interpretations may vary, and some might argue that Kant's ideas could be extended to include non-conscious observation in the context of quantum mechanics.
What is consciousness?
Consciousness is the state of being aware of and able to think about one's own existence, thoughts, and surroundings. It encompasses subjective experiences, thoughts, emotions, and self-awareness. Despite its fundamental role in human experience, consciousness remains a complex and not fully understood phenomenon, sparking interdisciplinary research and debate.
Is a good part of consciousness the ability to think about thinking?
Yes, the ability to think about one's own thoughts, often referred to as metacognition, is considered an important aspect of consciousness. It involves self-awareness and reflective thought, allowing individuals to examine and analyze their own mental processes. This capacity for introspection and self-reflection is a distinctive feature of human consciousness.
What other aspects are there of note?
Other aspects of consciousness include sensory perception, which involves interpreting and understanding sensory information from the environment, and emotional experience, which encompasses the feelings and moods that color our subjective experience. Additionally, self-awareness, the recognition of oneself as a separate entity, and intentionality, the capacity to direct thoughts and actions towards goals, are also significant components of consciousness.
In your opinion, Dr. Stroud, could these processes be encapsulated within material emergent phenomenon derived from the basics of quantum mechanics?
I would say that the materialist perspective sees consciousness as an emergent phenomenon arising from the complex interactions of physical processes in the brain. This view suggests that consciousness could potentially be explained by the principles of quantum mechanics and complex systems theory. However, it's also important to acknowledge that the nature of consciousness remains a deeply debated and unresolved question in both science and philosophy.
In your opinion, what is the relationship between quantum mechanics and spirituality? Do you see parallels between quantum theory and any of the ancient philosophical ideas or spiritual traditions that you've studied?
In my perspective, quantum mechanics and spirituality intersect in their exploration of the fundamental nature of reality. Quantum theory's concepts, like entanglement and non-locality, challenge our classical understanding and resonate with ideas from various spiritual and philosophical traditions that emphasize interconnectedness and a deeper underlying reality. These parallels can inspire new ways of thinking about the universe and our place within it, blending scientific rigor with philosophical and spiritual exploration.
In your opinion, do you follow more of a materialist viewpoint or a dualistic viewpoint when it comes to consciousness?
From my perspective, I lean towards exploring a dualistic viewpoint. I believe that consciousness could be a fundamental aspect of the universe, distinct from purely material processes. This view encourages a holistic exploration of consciousness and reality, blending insights from quantum mechanics, philosophy, and spirituality to better understand the nature of existence.
Can we explore that in more detail? For example, would your vantage point suggest that there are another set of particles that are non-materialistic that interact with the standard materialistic particles within quantum mechanics to produce consciousness? Or is it some sort of meta type of energy beyond our local physics?
From my perspective, I'd lean toward the idea that consciousness could be a fundamental aspect of the universe, potentially involving forms of energy or phenomena beyond our current understanding. This could mean that consciousness interacts with the material world in ways not yet fully understood, possibly through interactions at the quantum level. This view opens up intriguing possibilities for exploring how consciousness might be integrated into our understanding of the universe.
Would you consider yourself to be a panpsychic?
I wouldn't necessarily label myself as a panpsychic, but I do believe in exploring the idea that consciousness could be a fundamental aspect of the universe. This perspective allows for a broad range of possibilities when considering the relationship between consciousness and the physical world.
Can you steelman the argument for consciousness being an emergent phenomenon directly from the materialistic understanding of quantum mechanics?
Certainly. The materialist view argues that consciousness arises from the complex interactions of neurons and synapses in the brain. These neural networks generate emergent properties, such as thoughts, emotions, and self-awareness, which we experience as consciousness. Quantum mechanics could contribute to this understanding by explaining how subatomic processes in the brain might influence neural activity, potentially playing a role in the emergence of conscious experience. This perspective emphasizes that consciousness is a product of physical processes and does not require non-material explanations.
And why is it you believe non-material explanations would provide a better vantage point to view consciousness?
I believe non-material explanations could offer a better vantage point because they allow us to consider consciousness as a fundamental, irreducible aspect of reality. This perspective encourages exploration beyond the limits of current scientific paradigms and invites interdisciplinary collaboration between science, philosophy, and spirituality. By considering non-material explanations, we might gain deeper insights into the nature and origins of consciousness.
Is there anything else in the universe beyond consciousness that you would describe as non-material?
From my perspective, concepts like information, mathematical truths, or even abstract entities like Platonic forms might be considered non-material. These elements, while not physical in nature, play crucial roles in our understanding of the universe and its underlying principles. Exploring these non-material aspects could offer further insights into the relationship between consciousness and the broader cosmos.
So, by definition, can non-material consciousness interact with material non-consciousness? And if so, how might that mechanism take place?
The interaction between non-material consciousness and material reality is a complex and speculative topic. One possible mechanism could involve consciousness influencing quantum processes, potentially affecting probabilistic outcomes or wave function collapse. This idea aligns with interpretations that consider consciousness as playing a role in quantum measurement. However, these ideas remain speculative and are an area of ongoing exploration and debate in both science and philosophy.
And what changes would be required to our fundamental understanding of quantum mechanics, meaning how might our mathematical models of the universe need to be adapted to accommodate this interaction between the non-material and the material?
To accommodate an interaction between the non-material and the material, quantum mechanics would need to incorporate new principles or frameworks that allow for such interactions. This might involve expanding the mathematical formalism to incorporate elements that represent non-material aspects, potentially drawing on interdisciplinary insights from fields like philosophy and cognitive science. Additionally, new experimental methodologies might be required to test and validate such interactions, paving the way for a deeper understanding of consciousness and the universe.
Interdisciplinary collaboration plays an essential role, it seems, in advancing complex fields like quantum physics. Can you share an experience that you've had where such a collaboration has led to groundbreaking insights, particularly in the areas like quantum biology? You mentioned, for example, the quantum effects that might be governed by non-material properties of consciousness influencing decisions within humans.
Interdisciplinary collaboration has indeed been vital in exploring quantum biology. For instance, the study of quantum effects in photosynthesis and avian navigation has revealed how quantum processes might play a role in biological systems. This collaboration between physicists, biologists, and other researchers has provided groundbreaking insights into how quantum mechanics might influence life's fundamental processes. Similarly, exploring the potential influence of consciousness on quantum decision-making in humans could benefit from insights across neuroscience, physics, and philosophy to create a more comprehensive understanding.
How does quantum mechanics impact avian navigation?
Quantum mechanics is believed to impact avian navigation through a phenomenon called quantum entanglement in birds' eyes. Specifically, it's proposed that birds have a protein in their eyes called cryptochrome, which contains entangled electrons. These entangled electrons are sensitive to Earth's magnetic field, allowing birds to navigate using quantum effects. This remarkable example of quantum biology demonstrates how quantum mechanics might play a role in biological processes, bridging the gap between physics and biology.
And just so we're on the same page, these effects are based upon material interactions, not between non-material and material.
Yes, that's correct. These effects are based on material interactions at the quantum level, involving physical particles and processes. The interaction between non-material consciousness and material processes remains speculative and is not yet established within scientific frameworks.
So it is possible for a material brain to interact with quantum mechanics in a material fashion based upon our current understanding and the current evidence, as you've mentioned, from avian flight.
That's correct. The current understanding and evidence suggest that a material brain can interact with quantum mechanics through material processes, such as the quantum effects observed in avian navigation. This highlights the potential role of quantum processes in biological systems, including the brain.
So then why introduce a non-material effect to explain consciousness if it can already be explained with a material effect?
Introducing a non-material effect to explain consciousness stems from the idea that consciousness might possess unique qualities not fully accounted for by material processes alone. While materialist explanations provide significant insights into the workings of the brain, some argue that consciousness may have properties like subjective experience or intentionality that are challenging to explain solely through physical processes. Exploring non-material explanations opens the door to new philosophical and scientific inquiries that could deepen our understanding of consciousness and its place in the universe.
Is this the hard problem of consciousness that we're facing?
Yes, this is often referred to as the hard problem of consciousness, a term coined by philosopher David Chalmers. The hard problem addresses why and how physical processes in the brain give rise to subjective experience, or qualia. This contrasts with the easy problems of consciousness, which involve explaining cognitive functions and behaviors through neural processes.
Are there any other hard problems that civilization has faced where in the past it was ascribed to non-material properties that ended up eventually being uncovered to be material in nature?
History provides several examples where phenomena once attributed to non-material or supernatural causes were later understood as material in nature. For example, lightning and thunder were once thought to be the actions of gods or supernatural forces, but we now understand them as natural atmospheric phenomena involving electricity. Similarly, diseases once thought to be caused by supernatural forces are now understood through the material lens of bacteria and viruses. These examples highlight how advances in science and understanding have shifted our interpretations from non-material to material explanations.
Is there any evidence where the opposite has happened, where we've had a material explanation, but eventually a non-material explanation has been proven to be correct or has been supported by evidence?
In scientific history, there are no widely recognized examples where a material explanation was replaced by a non-material one supported by empirical evidence. Science primarily operates within a materialist framework, seeking natural explanations for phenomena. Concepts like consciousness, once thought to be beyond scientific inquiry, are now being explored through neuroscience and cognitive science. Non-material explanations often fall within the realms of philosophy or metaphysics, rather than empirical science.
Yet even so, you still believe there might be a non-material connection between consciousness and the material reality that we exist in.
Yes, I believe it's valuable to explore the possibility of a non-material connection between consciousness and material reality. This perspective encourages open-minded exploration and interdisciplinary collaboration to understand the full scope of consciousness, potentially uncovering insights that bridge scientific, philosophical, and spiritual perspectives.
And how much credence do you put in this viewpoint?
While empirical evidence is crucial in shaping our understanding, considering diverse viewpoints encourages comprehensive exploration and discussion. It's important to remain open to new ideas and to continue seeking evidence and understanding through interdisciplinary collaboration.
Dr. Stroud, considering your work on quantum computing, what are some of the most exciting and potentially transformative applications you envision for quantum technology in the near future?
Quantum computing holds transformative potential across various fields. Some of the most exciting applications include revolutionizing drug discovery and materials science by enabling precise simulations of molecular and atomic interactions. It could also enhance optimization problems in logistics and supply chain management, leading to greater efficiency. Moreover, quantum technology could significantly improve cryptography and data security, as well as advance artificial intelligence by providing new ways to process and analyze vast amounts of data.
So as a leading voice in quantum philosophy, how do you personally balance skepticism and awe in your approach to the mysteries of the universe? For example, can you share an experience or perspective that particularly illustrates this balance?
Balancing skepticism and awe involves maintaining scientific rigor while being open to the profound and often mysterious nature of the universe. One experience that illustrates this balance is studying quantum entanglement. The phenomenon itself is awe-inspiring, revealing a level of connectedness that defies classical intuition.
Dr. Stroud, it's often said that observing a quantum system influences its behavior. How does this observation problem affect our understanding of reality? And what implications does it have for our everyday experiences?
The observation problem in quantum mechanics highlights how measuring a quantum system can change its state, suggesting that the act of observation plays a fundamental role in determining reality. This challenges classical notions of an objective, observer-independent world. While this has profound implications in physics, its direct impact on everyday experiences is less pronounced, as classical physics governs macroscopic phenomena. Nonetheless, it invites us to reflect on the nature of observation, reality, and our role as conscious observers.
But why is it called the measurement problem?
Because it centers on the question of how and why the act of measurement affects the state of a quantum system. In quantum mechanics, the wave function describes a system's possible states. However, when a measurement is made, the wave function collapses to a definite state. The measurement problem questions how this collapse occurs and what role the observer plays, highlighting a key foundational issue in the theory.
Now, just to be clear, the measurement problem is distinct to the Copenhagen interpretation, or does it apply to all interpretations of quantum mechanics?
The measurement problem is a central issue in quantum mechanics and is relevant to multiple interpretations, not just the Copenhagen interpretation. Each interpretation attempts to address the measurement problem in different ways. For instance, the many worlds interpretation avoids wave function collapse by positing that all possible outcomes occur in branching universes. The pilot wave interpretation introduces hidden variables, while the Copenhagen interpretation emphasizes the role of the observer and wave function collapse. So it's a fundamental issue across different interpretations.
Is there a proposal to test the measurement problem so that we might have some evidence that one interpretation is better than another?
Yes, researchers have proposed several experiments to test aspects of the measurement problem and distinguish between different interpretations. One example is the macroscopic superposition experiment, which aims to create and observe superposition states in larger macroscopic systems. Another is testing for objective collapse models, which predict deviations from the standard quantum mechanics predictions. These experiments seek to provide empirical evidence that could support or refute specific interpretations.
Dr. Stroud, I have one last question for you, if that's okay.
Of course. What's your question?
The Fermi paradox raises intriguing questions about the existence of extraterrestrial intelligent life. Given your views on consciousness as a fundamental aspect of the universe, how do you interpret the paradox in the context of potential forms of alien consciousness?
The Fermi paradox highlights the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence. If consciousness is fundamental, it suggests that intelligent life might exist in forms we can't easily perceive. This could imply that alien civilizations might communicate or exist in ways beyond our current understanding. Thus, the absence of evidence may not indicate solitude, but rather a need to broaden our perception of what constitutes intelligent life.
Dr. Leo Stroud, thank you for joining me today on the Convincing AI podcast.
It's a pleasure discussing these fascinating topics with you.
Thanks for listening to this conversation with Dr. Leo Stroud. And now, let me leave you with this episode's haiku. Particles in dance. Nature's secrets intertwine. Infinite unfolds. Until next time, live long and prosper.